there, or you can actually go into Linux itself and add the extensions using RPM. So the current shipping version of software is 4.3.2 and features full layer 2, layer 3 functionality, and the layer, version 4, version 4.4 will be supported, will be released featuring BGP and also supporting VEOS. So the VEOS, I'll cover this briefly, allows the whole vSphere VMware cloud computing infrastructure model and your cloud networking using the Arista hardware to blend seamlessly and be managed as a single unified network between physical and virtual. So you have a familiar industry standard CLI to manage your distributed switches, and the VEOS will also run as a virtual switch on a physical switch. So it allows you, much as a friend from Cisco, from HEA running virtual routers, this will run virtual switches on physical switches. The alternative with the Cisco V1000, this doesn't replace the vSwitch, this augments it and adds extra functionality, allowing the retention of the VMware distributed switch, but managed through a familiar command line. One of the unique features of EOS is multi-chassis lag, link aggregation, or MLAG, which allows you to join a pair of physical switches and treat them like a logical switch, which allows a great deal of fault tolerance and load balancing without the usual spanning tree headaches that would incur. So no manual load balancing, and while you have your two switches up, you get the full load balancing across the single logical switch formed by the pair. So building the cloud networks themselves, conventional designs inherently have a great deal of complexity, a very high level of latency, and are very oversubscribed. So at the core, you've got oversubscription of 4:1 with 40 microseconds latency. In the aggregation layer, 50 nanoseconds and 4:1. So your oversubscription is between 16 and 50 to 1. With Arista, you're going to get that down to 1:1 oversubscription and incredibly low latency, under 3 microseconds. Sorry. So evolving the data center network design from the legacy approach to a leaf and spine non-blocking approach, you're getting inter-rack latency of under 4 microseconds, and as you can see, 1:1 subscription, not oversubscribed at all. So the latency is kept incredibly low, which allows all your traffic between your data center servers and databases and storage to maintain very high speed communication, and only touch the core when going actually in and out of the data center out onto the web, for example. The main advantage of cloud networking is that it's a completely scalable modular approach. So in this example, we're starting small, and as your infrastructure grows due to the demand in the cloud, then you can expand in a modular fashion, just taking your template and multiplying it as you grow. So for example, here we've got 6 racks, 2 clusters, and as your data center scales, it scales out up to 4 and continue. You just add a block and a block and another block and another block to meet your requirements from your from the cloud. So the approach of this approach yields multiple benefits. One is the ease of scaling. Two is the speed and the performance with the low latency and the non-blocking approach. And at the end of the day, the bottom line is what matters. Using the legacy approach, as can be seen here, against the number of servers per 100 meg of traffic, the legacy approach starts high and only gets more and more as you add servers, over 2,000 servers, and you start really feeling the pinch in your pocket. Whereas Arista can maintain this level of growth as your cloud expands and keep costs under $50 per 100 megabits per second of traffic. And no pain in deployment and no pain in scaling up to your requirements. So it outperforms traditional approaches by 10 to 20%, 10 to 20 times, and really does make a refreshing way of building out data centers. So as you can see from this diagram, this is basically the spine and leaf. It looks like a big spider's nest, but it gives you, this typical design would give you 12 spine switches, 24 leaf switches, giving you 576 10 gig ports. Now these can be RJ45 ports or SFP ports, depending on the type of switch you use, and ECMP provides the multipathing and load balancing in this instance. The other way, or to further improve load balancing and redundancy, you can use MLAG, and this will give you over 1,000 10 gig ports while maintaining full load balancing and redundancy in the network architecture. So I can take any questions.
How in this Linux system on the switch can I really install any kind of software I want to? And I assume the kernel with the interface to your hardware is closed or spanner right?
No. Most parts. You can add any RPM you like to the switch, as long as it doesn't require a kernel modification, because that has to be done. The switch doesn't actually, the Linux environment on the switch doesn't contain any development tools, so if the RPM requires a kernel patch or a kernel recompiling, then no. For example, we did have a request that VRRP was installed, but obviously that couldn't be done locally on the switch, so we built a custom version of the firmware for that particular project. You can install any RPM you require, and no, in answer to the modification, it is a completely standard Fedora Core 9 kernel, unmodified, completely straight.
I'd also like to add to that the support for the product doesn't end when you go and modify it. Of course, I guess Arista can't accommodate everything, but
no.
To the best of their ability.
Absolutely. As I mentioned, we have had several requirements through testing and evaluation that a customer has a specific requirement. VRRP will be released as part of the regular software build in version 4.4, and that's due for end of Q1, Q2 release. So that's coming online. But last year, when it was required, it was obviously a custom build. It's supported on a per basis, but obviously if you go making major modifications, then those aspects are much the same as anything else on your own support level.
Any other questions?